All right, so to finalize our lecture on data cleansing, we can see that data is not always perfect, and then there's a need to be able to find and replace our missing data. Um, so the first thing that we did is that we had previously found that there was some missing values in the miles, and what we did is we replaced that with the average value. We also found that there was an error in the life of tire where the maximum value was 601, and the possibility was that they forgot to put a decimal place. It should have probably been like 60.1. So that was modified. And now we had a tread depth where the tread depth, the maximum was a major outlier at 16.7. And so what we did is we just deleted that observation entirely. So you can see we use different techniques in order to be able to modify our data. Now I'm going to do one more thing. I'm going to go ahead and select all of this, and I'm going to go ahead and do an insert box plot. And actually that doesn't work that great. I'm going to go back here, and I'm going to do insert box plot that way, so we can now see that this one here is, this first one is going to be the tread depth, or the life of tire, excuse me. Move this over. All right. And so this is that. And what I'm going to do is I'm going to hit copy paste, and then move this over, and then this now is the tread depth, and then copy paste and move this over, and this is going to be the miles. All right, so I'm looking at all of these data items. I'll move this down here. I don't need that right at the moment. And it looks like I still have some outliers. And so I'm going to probably let these be in this particular case. I have some other outliers in miles. And then when I look at the outliers in the tread depth, there seem to be on the low end. And as an analyst, I might run my analysis and then determine whether these outliers are really affecting our data or not. So let's go back to our lecture with our PowerPoint. And so software is going to help us with this. Now inside the PowerPoint, it talks about a lot of things that we've already gone over. I looked at the mean and the standard deviation to be able to use those to help identify where certain errors could exist. And here we did minimum and maximum. And we also did a scatter chart to identify. And this, of course, is tread depth and, of course, miles. And then we're able to see that XY scatter chart. So one of the things to be concerned about, especially when it comes to data cleansing, is this whole idea that that the variable representation may be so excessive that it's going to be impossible to do an analysis on everything and do some type of imputation. This is typically related to dealing with big data. And it has to do with the fact that you might have too many variables recorded. And remember, variables are the items at the top of your spreadsheet. So variables are up here. And sometimes those variables could be in the range of like 100 or even like 1,000 variables. And if that's the case, you want to make sure that when you're managing your data cleansing, that you do it appropriate to that particular data set. But when you have that many, those many variables, like that are like 1,000 or more from left to right, we also get into the idea of dimension reduction, where we might be able to condense these by using some mathematical techniques like vectorizing of variables. So when you get into advanced mathematics, look at matrix algebra, you create small vectors. Usually they're a one size vector, of variables. So a vector might be something like this, and it will be down an X number of variables or N number of variables. And that might represent an entire observation that is related. So these are advanced techniques when it comes to dealing with data cleansing. Because you might have high variable representation, you decide instead of doing any kind of imputation, you decide to do some dimension reduction. And that also helps with your analysis. Okay. So with that, we are at the end of data cleansing. And if there's any additional questions, feel free to reach out. Thank you.